Hi, this is Anthony Cummins, Physics 221, video homework 1. The objective for this homework is I can utilize velocities at different time points to determine the net force corresponding to an interaction in 3 dimensions. So for this objective, I made a problem stating, suppose a car with a mass of 1,000 kilograms is traveling at a velocity of 246 meters per second and comes to a stop after 3 seconds. What was the net force needed for the car to stop? So from the problem, I had identified some key equations needed. The change in momentum vector is equal to the net force vector times change in time, and the momentum vector is equal to mass times the velocity vector. So then for solving it, first thing you have to realize is you need to rearrange the equation for change in momentum to solve for the net force. And you do that like so, just by dividing the change in time. And then you can plug in the values to solve for change in the net force. So then you have to calculate the momentum vector using momentum equals mass times the velocity vector by plugging in those values. 1,000 kilograms for the weight of the car, and then the velocity vector is 246 meters per second, and then simplified down there. And then third step, you need to calculate the change in momentum. So you take the final momentum, which is 0.000 kilograms per meters, or kilograms meters per second, and subtract the initial momentum, which is 2,000, 4,000, 6,000 kilograms meters per second. You get that negative momentum vector there, change in momentum vector. So then you can go ahead and solve for the net force vector. Just plug in the change in momentum vector to the top, and then plug in the change in time, and then solve. Final solution is negative 666.667 for the x-coordinate, negative 1,333.333 for the y, and negative 2,000 for the z. And then units kilograms meters per second squared or newtons.